Hello viewers, in today's class we are going to discuss another problem from integral inequalities. So in this lecture we have one very important problem from estimation of integrals. So here we have to prove that the value of this integral that is from pi by 4 to pi by 3 sine x over x, it lies between square root of 3 over 8 and square root of 2 over 6, right? So we'll prove how to prove that the value of this integral, it lies between these two numbers. So let us start. So now let us take this integral as I. So here we have the integral I, that is from pi by 4 to pi by 3, and the integrand is sine x over x dx, right? So let us take a is equal to pi by 4, the lower limit, and the upper limit is pi by 3, and the integrand as f of x, that is sine x over x. So here I will make use of an important theorem from integral inequalities, and the theorem goes like this. The integral of f of x from a to b is greater than or equal to small m times b minus a, and it is less than or equal to capital M times b minus a, right? So this is a very important inequality which is used to solve a lot of these kind of integral inequalities. So here this f of x is sine x over x, right? A is pi by 4, b is pi by 3, right? Now this small m is the absolute minimum of f of x, right? So the small m is the absolute minimum or the global minimum of this function f of x in the interval that is a comma b, right? And this capital M is the absolute maximum value of f of x in the interval a comma b, right? So the small m is the global minimum and the capital M is the global maximum value of this function f of x in the interval a comma b. So now let us substitute the values from here to this inequality, right? See, we do not know the value of small m and capital M, and we are going to find out the value of small m and capital M. So now we can write m b minus a. B minus a can be obtained as pi by 3 minus pi by 4. So this is 12. The LCM is 12. We have 4 pi minus 3 pi. That is pi over 12. Right? So we have m times pi over 12. And here we have the integral from pi by 4 to pi by 3 sine x over x dx. And here we have capital M times pi by 12. Right? So now once we find the value of small m and capital M, we can easily arrive at this inequality, right? So to get the value of small m and capital M, let us investigate this function f of x, that is sine x over x. So let us differentiate f of x with respect to x, right? So f prime of x is the derivative of sine x over x, and here I will make use of the quotient rule. So we have x, the derivative of sine x is cos x minus sine x, and then the derivative of x is 1 divided by x square, right? So we have x cos x minus sine x divided by x square. So now let us take cosine of x common in the numerator. We have cos x, then we have x minus sine x over cos x divided by x square, right? So this can be written as cosine x over x square, and here we have x minus tangent of x, right? So the derivative of f of x is f prime of x, which is equal to cosine x over x square, x minus tangent of x. So now from this expression, we can easily see that in the interval that is from pi by 4 to pi by 3, right? Actually, pi by 4 is 45 degrees and pi by 3 is 60 degrees, right? And we are in the first quadrant, right? Okay, so in this interval, we can see that cosine of x is positive, right? And x square is positive, and here we have x minus tangent of x, right? And we can easily see that in the interval 45 degree to 60 degrees, this x is less than tan x, right? It means x minus tangent of x is less than 0. We can verify this result by taking some particular value of x lying between this interval. For example, say, let us take x is equal to pi by 4, right? See, here we have pi by 4, and tan pi by 4 is 1, right? And if we divide 3.14 by 4 minus 1, so this quantity is obviously less than 1. So this is less than 0 or a negative quantity, right? So x minus tan x is less than 0. So here we have a negative sign. So we can now conclude that f prime of x is a negative quantity, or it is less than 0 in this interval that is from pi by 4 to pi by 3. So the derivative of f of x, which is f prime of x, is less than 0 in this interval. So this suggests that f of x is a decreasing function in the interval pi by 4 to pi by 3, right? So this is the investigation about this function f of x. So we have concluded that this function is a decreasing function in this interval, right? So the value of absolute minimum can be obtained in the for x is equal to pi by 3. So viewers, f of x is a decreasing function. So the value of m can be obtained at this value of x, right? So for x is equal to pi by 3, we'll get the absolute minimum because f of x is a decreasing function. And for x is equal to pi by 4, we'll get the maximum or the absolute maximum value of this function f of x, right? So m is now equal to sine that is pi by 3 divided by pi by 3. So sine pi by 3 is sine 60 degrees, and that is equal to root 3 over 2. So this is pi by 3. So this is 3 root 3 over 2 pi, right? Okay. Now the value of capital M can be obtained at this value, that is pi by 4. So we have sine pi by 4 divided by pi by 4. Sine pi by 4 is 1 over root 2. This is pi over 4. So this is 4 over pi times square root of 2, right? So now we'll substitute these values in this inequality. So now we can write this inequality as m times pi by 12. M is 3 root 3 over 2 pi times pi over 12 less than or equal to this integral. We can write this integral as I, and we have here m is 4 over pi root 2 times pi over 12, right? So now this is 3 fours are 12, and here pi and pi get cancelled. So we are left with root 3 over 8. 2 times 4 is 8. And here we have 4 threes are 12. So we have pi and pi get cancelled. So we have here 1 over 3 times square root of 2. So now this term 1 over 3 root 2 can be written as 1 over 3 root 2 times square root of 2 over square root of 2, rationalizing the numerator and denominator. So this is root 2 over root 2 times root 2 is 2. So this is 3 times 2, so root 2 over 6, right? So we have root 3 over 8 less than or equal to I, that is less than or equal to root 2 over 6. So viewers, this is our desired inequality.